just going to get the attendance this period, and then I'll get it hopefully next period. If you help me and remind me.
Otherwise, Margaret's got it.
I get yelled at. Alright, missing a Rachel, missing a Jonathan. I do not mind.
Yeah, I didn't get a check on that.
Missing a Moshe. And an Alizola. And a Julia.
She's on check.
I didn't get a check
Or whatever that is.
Alright, I will check your checks in a few minutes.
Did I ever get a check? I don't think I know.
You didn't get a check.
Oh.
You don't think anybody got a check?
No one got a check. Did anyone get a check?
Yeah, that's 31. We're talking about 32.
I didn't get a check on 31.
Oh.
Shots.
Hold on, let me see.
Hold your horses.
Possible. Carpulus. I did not check 32 for anybody.
Alright. So just check it first.
And 31, Hannah, I did not see you 31. So whatever, I just hand those back in again, please. Thank you.
Want to put the new ones in?
Not the new ones yet. Just so first person, just leave it on your desk, please. Thank you so much.
Hello.
I'd like to start with 2 homework questions, if there are any homework questions.
I got one.
Ruth?
Okay, integrate from pi over 6 to pi over 2.
No.
Open parentheses. X plus 2 over sine squared x dx.
Sine squared x. Is that your question?
Yeah.
So this is now, we've seen questions similar to this, but as indefinite integrals, where you have a plus c. This is now an indefinite integral. The process is the same. The only difference is there is no plus c. We evaluated f of b minus f of a. What you're not seeing, if you got stuck in this question, is you need to look at this in another way. Okay? It just comes from knowing the trig. Josh?
Cotangent. Cotangent squared.
Strength 1. And?
Cosecant squared. 2 times cosecant squared.
Yes. So,
So
you
then
see that 1 over sine squared is that?
Yeah.
So let me write that. And now when you're asked to integrate it, you're just happy as can be. You know how to integrate x. What do you get?
X squared over 2.
And you know how to integrate cosecant squared x because you know the derivative of something is cosecant squared x. Don't you check?
you're negative.
Cotangent is equal to negative cosecant.
So there is a 2 there, and it is not somebody else said cosecant. It's just negative cotangent of x because the derivative of cotangent of x is negative cosecant squared x. You need this to take care of that as negative to make it positive. If this were a indefinite integral, we have a plus. It's not. We're going to evaluate from pi over 6 to pi over 2. So in finishing this question, we're going to plug in pi over 2. This becomes pi over 2 quantity squared over 2 minus 2 times the cotangent of pi over 2. The tangent of pi over 2 would have been undefined, but the cotangent of pi over 2 is not undefined. Does anyone know what the cotangent of pi over 2 is?
Yeah.
It is. So that would be our f of b, take away. Now let's do f of a. At pi over 6, it becomes pi over 6 quantity squared over 2 minus 2 times the cotangent of pi over 6. The cotangent of pi over 6, the easiest way is first to know the angle is what in degrees? Probably could tell me the tangent of 30 degrees, couldn't you? What is it?
1 over square root of
So the cotangent would be,
square root of
that's incorrect, would be,
square root of
thank you. And so to finish the question, this of course becomes pi squared over 8 minus 2. This becomes pi squared over 72. I'm sorry. Pi squared over 72, see that? I'm about to make an error, another one. What's my error? Why? It's very easy to make those errors. Please try not to. And this would probably not be the answer in the back of the book. These are, after all, like terms. This wants to be 72. Be generous. How could you make this 7? So in fact, we have 9 pi squared over there. Take away pi squared over that, which is 8 pi squared over that. But 8 pi squared is saying, reduce me. Eh? Yeah? See, that would be, I'll take one more homework question after this one. For now, show me.
Okay, take the definite integral. Okay, I changed. Do you have the book on you? I changed it.
On me? You have one of the drawers.
I changed it.
Right there. In the drawer. While he's doing that, we can start talking to you about 2 things we're going to do today. We're going to learn the first and the second fundamental theorem of integral calculus. Sounds pretty serious. Yes.
It's 1 over x squared dx from 1 to 3.
So this looks like a hard question unless, don't leave it there. Unless you see it another way. How do you want to see it? Russ,
X to the negative 10 to the power.
see that?
Yeah.
So let me change it to that. Stay. And now it just wants to be integrated. It's just the power of x. When you integrate, we do.
So it's x to the negative 1 over negative 2 over negative 1.
Yeah, so that's it. Evaluate from 1 to 3. To make this make more sense and easier to do, I'm just going to do the algebra here and write it as minus 1 over x. Is that okay? From 1 to 3. And then just factor out the minus. It's there. When I plug in the f of b, it's 1/3. When I plug in the 1, it's 1 over 1. This wants to be minus 2/3. That wants to be plus 2/3. And that's your answer. By the way, in performing a definite integral just by itself, the answer can be negative. There may be certain applications for which a negative will make sense. If we're finding at some point an average temperature over a period of time, for example, it certainly can be negative. If it's an area, it doesn't make sense. It can't have a negative area. If it's the volume, it can't be negative. If it's somebody's height, it can't be negative. I'm going to go through today's lesson now, and then, if there's more questions with my height, I'll answer your questions. Hi. So, we did a motion on a line. We did S of t, V of t, and A of t. V of t stood for
Velocity.
also gave an equation for V of t squared minus 2t. That means at different moments in time, we could state the velocity just from this equation. Got it? If I wanted the acceleration equation, what would you do to the velocity equation? John?
Take the derivative.
If I wanted the acceleration equation from the velocity equation, what would you do? Jason?
You would integrate it.
Yes, you would. What I'd like to do,
Wait,
Well, you just said
the
you said the same thing
from
again.
velocity.
You said acceleration from velocity.
what did I say? I meant position.
Okay.
If you wanted position,
Then you
he heard what I meant to
Yeah.
say.
I heard it.
So, I'd give me the position, that would be correct.
It's the replay.
What I'm not
Yeah.
is find the distance covered by this particle from time from 4 to 6. That would be t equals time 4 to time 6. I'd like to know how far it's going. Implied in this question, so you can see a little later on, it depends if it's moving left or right. Let's just determine after this question. For the velocities, what are the critical values for the velocity? It's easy. It's already set up for us.
0, 0.
And so let's see how it's moving. You know, even without knowing how it's moving, you know that it's not turning around anywhere between 4 and 6, yeah? So yeah.
Yeah.
At 1 second, what's the sign of velocity?
Negative.
And after 2 seconds, so it was moving a little bit. What's the direction of velocity? It was moving a little to the left, stopped, and it started on to the right. And certainly from 4 to 6, it's still moving to the right. Does that make sense? It makes sense. It's not an issue in this question. It will be in other questions. So essentially, if you could find the position at time 6 and the position at time 4 and do something to them, you'd know how far it traveled, wouldn't you? What would you have to do? So most people and subtract would be correct. So you're at the 100-mile marker, you were at the 86-mile marker, you can subtract to see you've gone 14 miles. That's a wonderful color of red on the thing. This kind of looks like f of b minus f of a, don't it? So actually, to find s of 6 minus s of 4, what we can do is integrate at t squared minus 2t with respect to t from where to where? And that's exactly what we want to do. What is the capital, or really it's a position function, but, or capital V function, what do you get here? What do you integrate? Huh? Yeah. So evaluate it from 4 to 6. When we plug into 6, we're not going to find out how far it is. We're going to find out where it is at time 6. When we plug into 4, we're going to find where it was at time 4, and when we subtract, we'll see how far. Let me understand what it is. And I'd like to encourage you to parenthesize what you get at time 6, take away, parenthesize what you get at time 4, and come up with an answer since you're not saying no. We'll just do the attendance quickly. Quickly as I can. Did I send this? I might have already sent this. But I don't know if I sent it. I'm talking to myself. Don't worry about me. I do it at times. I'll send it again. Maybe they'll let me slide on the later one. Okay. This is going to be interesting. It's an experiment. I'm sending it for period J now. All right, what's your final answer?
32. Yeah, 32 thirds.
We're good with that?
7 thirds.
Anyone else get this answer?
Not 7.
92. I got 92.
That's the same thing. 92 thirds is the same thing.
This is 92 thirds. Anyone else get this answer?
Yes.
Okay. Try to get this answer if you can, please.
See, so 92 thirds in one.
Excuse the interruption, Molly Grossman to the main office, please.
Really awful.